Hey there, welcome back to my YouTube channel. Today's video gonna be absolutely amazing because we are going to make the awesome Flappy Bird game by using JavaScript. Do you remember that we used to play this game endlessly in our parents' phones? To be honest, I snatched my father's phone again and again and play this game. And I suspect that this experience matches with you guys more or less. My great fathers would say, enough gossiping, let's get to work. By recalling my great father's words, let's first play the game. So in the right upper part of my screen you can see the Flappy Bird game. I am refreshing this page. So whenever I am pressing the space bar, the bird is moving forward without getting touched with the vertical bars. When the bird is touched with any vertical bar, the game is over. So in the left hand side of my screen you can see I already opened the Visual Studio Code. You just need to open the Visual Studio Code and make a folder called Flappy Bird. So I already made the folder as well. So I am just dragging the folder inside my VS Code. You also need to drag this folder inside the Visual Studio Code like this. So the second step is you need to make the files. The first file is index.html and the second file is index.javascript. So next you gonna need these three PNG files to use in your Flappy Bird game. So I am linking these files in my video description. You just need to download this file from my video description. Welcome back guys. So I am sure that you have downloaded all the necessary files from my GitHub and put them in the folder in which you are making the game. So it's time to make your hands dirty with code. First of all, I am moving towards the index.html file and I am bringing the boilerplate code by pressing Shift and 1. Secondly, we have to make the ground for the game. For that purpose, I am using the canvas tag with the following dimensions. Next, we are going to use CSS. We are using CSS in this file because CSS part is so small that we do not need to make a separate file for it. So at last, by using the script tag, I am linking the HTML and JavaScript file. Now I am opening the HTML file. As you can see, we have made a ground for our Flappy Bird game in the left upper corner of screen. Nextly, we are moving towards the JavaScript file to make the game from scratch. In the first line of code, we are defining the HTML document to find the canvas element using the query selector canvas. The canvas variable now holds a reference to the selected canvas element, allowing us to interact with it through JavaScript. Next, we obtain the 2D rendering context of canvas and store it in the ctx variable. The ctx variable is going to provide us a set of functions and properties that we can use to draw different shapes and images. Next, we are defining an object called bird that represents the properties and initial state of our bird character. Now I am going to describe the dimensions of bird using Notepad. So let's suppose that I have the HTML screen drawn on my Notepad. So on the left top part of the screen we are having the initial coordinates of the page and the canvas is defined by the following rectangle. Now we are going to define our bird object inside the canvas page. In the code, the x coordinate of the bird is 30 pixels, so we're gonna place bird 30 pixels away from x coordinate, which is approximately here. And the y coordinate of the bird is canvas height divided by 2 minus 20, which is approximately here. Vy is the initial velocity, which is 0 at the beginning. The initial acceleration gonna be 200 because when the bird moves down, the y coordinate is positive. At last, the width and the height of the bird is 50 and 40 pixels respectively. The columns variable is empty array. This variable is used to store column objects in our game. Columns are the obstacles that the bird needs to navigate through. Gap is set to 150 pixels. It represents the vertical distance between the upper and the lower column. The bird must fly between these gaps to avoid collision. The column velocity is set to minus 200 pixels per second. This value determines how fast the column moves horizontally across the screen. Column distance represents the horizontal space between pairs of columns, which is set to 200 pixels. Isn't is a boolean variable initially set to false. When the collision occurs or the game is over, this variable will be set to true. It serves as a flag to indicate the state of the game. Next, we are going to create an image object to store image resources that will be used in our game. This object is initialized with three properties, each represents a different image resource. By storing these images, we can load image files and use them in our game. Next, we are setting the source properties of our images object. Each property corresponds to a specific image resource used in our game. By assigning file paths to these properties, we specify the location of image files. The random function takes two numbers and return any random number between them. We will use this random function to generate columns with different lengths. Next, we are going to make a function called addColumn, which is going to add columns to the game. Inside the column function, we are generating random height by using random function. We are giving two parameters to random function. The first parameter is 30, which is minimum height of the column, and the second parameter is canvas.height minus 30 minus gap, which is the maximum height of the column. Now we are going to add columns to the columns array. We are actually creating a pairs of vertical columns for the bird to navigate through. The first object represents the upper part of the column because the y coordinate is 0. The second object represents the lower part of the column and hence the y coordinate become height plus gap. Next, we are going to make a function called isColliding. This function is used to determine whether the two rectangle objects A and B are colliding with each other or not. A and B are representing the game entities like the column and the bird. This function calculates the condition for colliding. If any of the following condition is true, that means that the objects are not colliding. I am going to explain the colliding condition by using Notepad because this part of the game is so crucial to understand. So the first condition to not collide is a dot x is greater than b dot x plus b dot width. We are having two rectangles A and B. If you draw the x coordinate and the width of b and add them together, the result is always gonna be less than a dot x if the objects are not colliding. And if the objects are colliding, this a dot x will be less than the summation. In the second condition, we are flipping the rectangles A and B and checking the colliding condition. The third and fourth condition checks whether the rectangles are colliding vertically or not. So long story short, the isColliding function is fundamental for deciding collision in game. In this line of code, we are initializing a variable called brief time. The performance.now method returns the current time step in milliseconds. Now we have game loop function, which is the most important function in our game. Constant dt calculates time elapsed since the last frame. It subtracts the brief time stamp from the current time stamp and divides the result by 1000 to convert it from milliseconds to seconds. dt is used to ensure smooth and consistent animations and movements regardless of the user's device performance. Here we update the previous time variable to store the current time stamp, allowing us to calculate the time difference in the next frame. The following functions are responsible for updating and rendering the game state on canvas. We will define these functions later. Finally, the conditional statement checks if the game has ended. If the game has not ended, it requests the next animation frame using requestAnimationFrame method, which effectively creates a loop. This loop continues to call game loop to update and draw the game on continuous smooth manner. The two lines of code calculate the velocity and the position of bird respectively. The following condition checks whether the bird is touched with the top edge of the canvas. If bird.y is less than 0, it means that the bird has collided with the ceiling and isEnd variable is set to true. In this part of code, we are iterating through each part in columns array and updating their horizontal positions based on the constant column velocity and the time elapsed dt. Additionally, we are checking for the collisions between the bird and columns. This part of code ensures that new columns are added to the game at appropriate intervals, creating a dynamic and ever-changing environment for the bird to navigate through. In this part of code, we are managing the removal of columns that have moved out of the left edge of the screen. By removing columns that are no longer visible, the game conserves memory and processing power. Next we will make the draw function. So now we are setting the fill color of the drawing context CTX to light blue, and we are using the image method of rendering context to draw an image onto the canvas. The next line sets the fill color to yellow, indicating that any shape or text drawn on canvas after this will be filled with yellow color. The following line draws the bird image on the canvas. It uses the draw image method to render the bird at the specific position. The following code snippet is responsible for rendering the column on canvas. It sets the fill color to orange and then uses the draw image method to draw each column image in its respective position. Finally, the conditional statement displays game over if the isEnd variable is true. Now the following line adds an event listener to the entire document. When key is pressed, onPress function will be called. The onPress function sets bird's vertical velocity to -300, simulating an upward jump, and the event listener for canvas clicks logs the x coordinate of click event to the console. Now we start the game by calling the following functions.